in this section 3.3, we're going to talk about Spark ML. So Spark ML, as we have discussed this before, is really one of the modules in Spark, and then sitting on top of Spark Core API. So the idea here is really to chain, right, all the transformers and estimators together to really compose different pipelines. So that's the concept, the key concept in Spark ML. So let's design chains of transformers together, right? So we will have to import all these things, right? Spark SQL functions, and then Spark itself, and also Spark SQL context. So as before, we have to create Spark sessions like this, get or create, and then give it a name, right? And then we want to create a Spark context like this, right? It sees our Spark context, and then we want to wrap this SQL context around Spark context to collect SQL context. So why we need SQL context is because we want to use all these SQL functions coming from PySpark. That's why we want to have, instead of just the regular Spark context, we want to have SQL context. Let's go ahead and run this, and then you can see, okay, so we have a SQL context, and then let's read some data. So say we want to look at Apple's closing stock price, right? And then find out the date on which Apple's closing stock price was the highest, right? So the input data frame looks like this. So the data is sitting in a folder data, and then we can just read it, right, using SQL context, right? Read.csv, that's how it works, and then you can actually look at .show, right? So this is one of the actions that we have covered in our last video. So you can actually do .show or functions, but this is similar to, you know, df.head, right? So just to give you the preview, and you can see date, open, height, low, close, adjusted close, and volume. So these are almost the columns that we have, and then a very convenient function is actually called schema. You can actually do like df apple.schema to tell you, right, the data types, right, and then all these other information, right? So all right, great. So this is kind of like similar to a df.info or df.describe, right? And then let's see, right? So we want to actually just keep only two fields, date and close, right? So close is our closing price, and then we want to say first order by closing price or close in descending order. So the first one we can actually do is, because we're using SQL context, right? So we can actually use all these functions from SQL. So dot select, right? We can do df number apple dot select two columns dot order by, right? And then close. This is the field that we want to use to sort it by, and ascending is equal to false. And then we want to do show, right? Top five. So this is how it looks like after filtering out other columns, just grabbing date and close, and then sort it by close. So it looks like, you know, this date is the highest, right? Which is, you know, yesterday. Okay, that's great. So now we want to put some more, you know, assemblers and transformers, right? So first of all, we need to import all these things, right? So you can actually see PySpark ML, right? .ml, .feature, import, min-max scalar, and vector assembler. Vector assembler is very, very useful. So let's take a look at one of the use cases, right? So we can actually say vector assembler, and our inputs, right, is close. Output, we can actually give it, say, features, right? So this is the name that we want to give it to the output column. So, and then what we want to do is vector assembler dot transform. We want to transform our original df apple into df vector, and then we want to show it, right? So the difference between, so the first data frame that you see here is really just our original df, and then the second one is df underbar vector, which has an additional column in here. So it's called features, right? So you can actually see that the closing, this column, right, it's being vectorized. It's actually a list. It's actually, this is a list where you can call it a vector, right? Instead of just like using close as is, we're actually converting it to a vector, right? So that's what you need to do, right? When you want to use ML, right? Spark MLlib, you will need to pretty much vectorize all of your features, right? Using vector assembler, as the name suggests, is pretty much just assemble your features into a vector, right? So this is the features, right? This is the feature, the column that we got from this vector assembler, right? Because that's how we named it. And then, all right, so let's look at the scalar, right? So min-max scalar is to put everything, into the same grid, right? Want to scale it, want to standardize it, right? So this is to say I want to use my minimum, maximum, and then put it, into a grid from like 0 to 1, right? So it's one of the, say, the standardizer. And then the same thing, right? So you have the input, which is our features now, right? So we want to use features as our input to the scalar. And then the output, we're going to call it scaled features, right? And then we do the same thing, dot fit, right, of our df vector, which is this one, right? And then we want to do dot transform of this, right? And then we want to then only select the two, right? Features and standard features. You can actually see our features, right, are like the vectors. And then standard features are actually just pretty much, numbers in with like decimal places, right? So these are pretty much from 0 to 1, right? You can actually look at this, right? And then what if you want to select more than just that, right? You can actually, of course, select more, but in this case, we're just going to select features and scale features. So you can actually see that it's really sequential. You do one thing first, right? Like adding this feature, we're converting close into a vector, right? And then do the scalar, apply the scaling or standardization on this the output from the vector assembler, right? So and so forth. So in our next video, we're going to talk about pipelines.